Okay, this video looks at addition polymerisation. For addition polymerisation, you have to have a double bond. It's like a type of addition reaction. So, this is the most basic example. We've got ethene. So the N implies there's a lot of ethene molecules. Okay, we don't know so many. We don't know how many. The ethene molecules are the monomers. Okay, and those monomers join together to make a polymer. So we go from ethene to polyethene. A polymer is a very long chain of monomers joined together. So here, this is what we call the repeat unit. You see these square brackets. This represents a repeat unit. So what happens is the double bond breaks and a bond can carry on from this carbon and one from this carbon to another section like this. So this would be two repeat units together, like that. And this repeat unit goes on and on. It goes on as many times as monomers we started off with. So if we started off with 1,000 of these, it would have 1,000 repeat units all joined together. When you join out any section of a polymer, it's always important to show there's a bond carrying on either end. Okay? Right, so let's go and have a look at some examples. Here we've got propene. Okay, so we start off with ethene, going propene. Now a common mistake is just to draw 3 carbons in a row, but it's only the carbons in the double bond which make the backbone of the polymer. So carbon 1 and 2 are here, 1 and 2, and then that's CH3. It's not a double bond, so it's not part of the main chain, it's branching off like that. Okay, so we go from propene to polypropene, the polymer. Here you can see originally there was a double bond there, it's not now, it bonds that way, and the CH3 coming off. And again there, so it's 2 repeat units there. Here's a common one, chloroethene, so we swap the hydrogen for a Cl, and the only difference is you have a Cl there instead of a hydrogen, making polychloroethene PVC. Again, 2 repeat units. But sometimes when the alkene gets longer it can be confusing. So a good method I think is to draw it out in this form. So here, draw it kind of flat. We've got the alkene double bond there. Now that's the only bit that's going to be part of the main chain. The rest, everything else is branching off. So I'm going to draw it like that. So I'm going to put, that's the centre. So that CH3 there is that one. That CH2 is there. And a double bond and CH3 here. I've drawn it here in the Z formation because both hydrogens are on the same side there. So if you draw it out like that, it makes it a lot easier. You can see you just get rid of the double bond and draw a line out from each carbon that were originally in the double bond, like so. Brackets around it, N. Okay, sometimes you have to work out what the original monomer was. So look at the chain. It's always going to be based. You're basically looking for 2 carbons. So only 2 here. Originally there was a double bond between them. Okay. So I'm going to put a circle around there because that's where it's repeating. So you're looking for finding the repeat unit. So basically you just find 2 carbons in the chain and ring them and everything that they're attached to around them apart from the other carbon chains. Okay? Like so, put a double bond back in and there you've got your monomer.